Hey, how's everyone doing? Good to see you here. Absolute. Maggie, Kenneth, Blake, Holly. Good to see everyone here. What do you want to do? What is the plan for today? What questions do you have? It is office hours part 2. I'm gonna have to readjust. I'm gonna get my headphones today. Oh god, it hurts my ear. I think these are like in-ear headphones that I'm using. They go around back, but I don't know. I'm trying to make them work, but maybe I'll take them out here. I don't know. Last day using them, I think. Last day using them. But if you have questions, it's the start of office hours, and we're just going to chill and get some work done. I had a question about the lottery thing. Yeah, what were you wondering? Drop it in the chat. Let us know. Here, we'll put on this one right here. Lottery question. Let us know. We did some randomness, so some lottery in 2-1. And Absolute, so good to see you here. Let's throw an extra 100 points. Mewbot is awake in the chat. This is a much more chill stream usually. I'm going to reorder the times. Actually, there we go. Take that earpiece out. I got one earpiece in. If there's only 2 possible outcomes, shouldn't it technically be 50-50? So there are 2 outcomes, but the probability of those outcomes are different. So, let's see here. Try. So, if something has 2 outcomes, we know what could happen probabilistically, like, that there is 2 possible things that could happen. 1, you win the lottery. 2, you lose the lottery. But the frequency of which they occur, like how often do people win the lottery? How often do people lose the lottery? Does that make sense to say it absolute? People lose the lottery way more often. So just because there's 2 options doesn't mean it's a 50-50 probability. It's just that there's 2 possible outcomes. Like think about, your favorite sports team. Like if you're talking about the Patriots in like 2016, the Patriots have like a very high probability. Some people asking the question, is there a 50-50 shot a door is locked? Well, think about this. If you go to a high security place, so like a great example, let's talk about this. Let's talk about probabilities of events. There we go. Okay, oh, that's feeling a lot better. It goes in my ear the wrong way. I'm a Falcons fan. Don't bring up Patriots. Sorry, Absolute. Here, let's head over to the main screen. Let's check it out. Probabilities and random events right here. Okay. Probabilities and random events. Okay. So stat tool 1. So if you were to go, a door is either locked or unlocked. This is mutually exclusive. Oh my gosh, what I hit. Mutually exclusive is a fancy word for meaning these 2 things can't happen at the same time. A door can't be locked and unlocked. So if you have a door, it is either in the state of a locked door or it's in the state of an unlocked door. Does that make sense? Absolute right there. That whatever door we look at will either be locked or unlocked. So a door, yep, okay. So we're good on that. So now if you look at this and you ask, is a door locked or unlocked? Well, let's go over here and let's say, let's go back to, let's say, Tennessee in 1925. I don't know. What's up, Alexander? So great to see you here. And I think those notes are wrong. I was messaging you on Discord about that. It's a good point. Back in Tennessee in 1925, a random back door on someone's house. So, what is the probability it's locked? What is the probability it's locked? So, random back door on someone's house, Tennessee back in 1925. I'm not a Tennessee historian, but I'm guessing. What do you think? What's the probability it's locked? Like, just if we were just hypothesize and make guesses, a random back door on someone's house in Tennessee in 1925, 100 years ago. I think they had just invented doors by that point. Doors, a new thing. Someone got some newfangled doors on their house. So, what do you think? Oh, thanks. I kind of like them. They're fitting a little weird in the ear. They're like special in-ear. I don't know. I might try to. I still don't understand how to use them properly. Trying my best. I'm probably gonna go get my old ones here in a moment. Like maybe later today. I'm trying to. My dad has some of those sure ones for his guitar. Yeah. Maybe tell me how to put them in my ear properly. It does like a pull and it's like hurting my eardrum. It feels like I'm just like, yeah. They're like the behind the ear ones. So yeah, they're really good for like, you could be up here like playing guitar and stuff. Yeah, and Alexander is really good stuff. They're good headphones and they're noise canceling too. So it's a little bit interesting. Oh, I know, absolute right. Yeah, swing by office hours, just chill and relax. Class is pretty energy. Office hours are more chill. So whenever some people love coming by office hours just to come in and you get some extra points. That's the way it works right there. You get points, you chill out here. So when you think about a random door, maybe 5% of doors are locked. But let's go to high security, 5% of time locked. High security NASA door, where they keep the aliens. Aliens kept here. No, extraterrestrial beings kept here. Extraterrestrial beings. Don't even let us spell that. Extraterrestrial beings. That's where they keep the extraterrestrial beings. And so with this right here, maybe 99.99999% of time locked. We gotta make a really good plan to get the alien out there, get ET home. But the probability of it being locked, even though there's only 2 outcomes, beans. I'd like some extraterrestrial beans. Grow them right there. Grow the crops on the moon. But the high security NASA door is probably going to be locked most of the time, whereas somebody's door in 1925 Tennessee is going to be not that often locked. So just because there's 2 outcomes doesn't mean it's a 50-50 probability that it's one of those outcomes. Does that make sense right there? Absolute. Just because there's 2 outcomes right here, like lottery, win/lose, you are way more likely to lose. So you're way more likely to lose the lottery than win the lottery, even though there's 2 lottery outcomes. You either win the lottery or you lose the lottery, or don't win, we could say. But there's only 2 outcomes to the lottery, and you either win the lottery or lose the lottery, and there's only 2 outcomes right there. So you either win or lose. Is this making sense? We got time for more questions. We could do some coding. Since even though surface level is exactly, even though there's 2 outcomes, it's a frequency thing. Like we can look at the frequency via math. Like math's a good way. For the first homework, question 5 is referring to the proportion of all movies, just R-rated movies that have a problem with it. Yeah, let's go check that out. Let's go make that performance metric and kind of talk through that a little bit here. So yeah, and everyone drop those questions in. We put the timestamps in the videos. I already got this right here with the probabilities and random events for 201. Let's go do the 474 question. Put those questions in the chat. So BAS 474, assignment 1, movie ratings. Question 4 was it, right? Question 5. Okay, let's go grab it. I'm gonna try to do similar but different work. So we're gonna go grab BAS 474. Let's go to assignments, movie ratings. And great job working early on this. Okay. Okay, we got it up and ready to go. Oops, wrong chat. Made smaller. And let's head over here. 926. And let's do this. Remember, drop those questions in the chat at any time, because now it's time for some 474 right here. Talking about how to deal with this. Yeah, you're welcome. Anytime. So we're going down here to question 5. You can actually click this. It's a bookmark throughout the whole thing. I don't know if you knew that, Alexander, but you can actually go through the chunks very quickly by just clicking the chunks, and then you will just go to where it's at. So you click right here and you've got all the bookmarks. So you could actually call this whatever you want. And Brian work, and then you can go back to it and see where it's at right here. Yeah, it saves a ton of scrolling, and I often forget about it, but it's little tips like this that are great to know. Then, of course, we also want to mention you can go into the viewer mode. It used to be over here in the older version of our studios. You're welcome, Absolute, anytime. 100 points. Thank you for swinging by. You can go to visual and see a visualization of it to see what your knitted document will look like, and you can still scroll through here. So let's go back to the source code and go to question 5 again and start working on this. Okay. Question 5. Wait, here it is right here. Add a column to the movie that contains the ratio of the movie's box office take divided by the movie's budget. Call this column performance. So got some HTML right there. I'm going to delete that. I don't want that HTML chunk right there. I don't know why that's there. I'm going to add my own R chunk right there. There we go. I'm going to do this code right here, which runs all chunks above. This button right here is the run every chunk above button. So there we go. It now has loaded in the movies. So this runs all code above right here. Good to go. Add a column that contains the ratio of the movie's box office divided by. Now, let's do some basic knowledge to start out. I know, run all chunks above is so helpful. We need to know this basic thing right here. And the basic thing is, how do we get to the vectors inside a data frame? Like if I want to look at, I'm going to work similar but different work. If I want to look at a vector inside of a data frame, how would I get to like the tomato meter? Oh, yes. Got those dollar signs right there. Great job. So I go movie, and it'll actually autocomplete, and then I do dollar sign, and we have the vectors. So a data frame is like an Excel spreadsheet, which looks like Excel. And we can see here we've got character vectors, director. So this should be the identifier. We might have some repeats like Ghostbusters, but Ghostbusters like 2020 or something like that, or 2019. It might repeat, but we should not have repeats for movies. We should have unique movie names. So that should be the identifier. Then we have things like director, but that should be a factor. So in truth, if we're working on this, we should probably take something like director, and we should put it around here and go factor. And then we should overwrite it, and this would overwrite it. I'm just doing a little bit of work right here to clean it up, but does that make sense? I just changed the way R sees that, Alexander. You don't have to do this. I'm just kind of showing that here's the data frame. That was a character. Now it's a factor with the different directors. So we could actually view the directors here by going to table and make a table of directors, and we could sort the table. Nicolas Cage? What? Of course he directed a movie, right? And then we could go decreasing equals true. And there's the decrease inversion. And then we could take the top 5 directors. There you go. Clint Eastwood. And think about what we've done right here. We have the top, or the most common, the most occurring directors: Tyler Perry, Steven Soderbergh, Steven Spielberg. A lot of names we know up here of the most common directors. And it's pretty easy to work with the variables and to get all this. So I just wrote a little bit of code right there to turn it into a factor. Top 5 counts of all directors, exactly. And you can do this to any variable. Once you turn it into a factor, like the star of the movie, we could literally take the same code we just have and go right here and find the top 5 stars by running a very similar code. Just take right here and do this. Change it to a factor. You'll see the variable type change right there to a factor. And now we can change here and change this to star. And there's the top 5 stars of movies: Nicolas Cage, Johnny Depp, Matt Damon, Dwayne "The Rock" Johnson, and Mark Wahlberg.
It doesn't matter.
Well, you're on the top of the list. So a lot of things we do are very similar working with this, and we could do distribution and all that too. But let's take a look at the following questions. What fraction of 0 through 1, a fraction of R-rated movies are successful? Now we have to create this metric. So once again, Brian does don't copy everything I do. Does that make sense, Alexander? Like, don't copy everything I'm doing, but tell me if you're stuck on something. But don't copy everything I'm doing, because I might do extra stuff you're not supposed to do. Like, we didn't have to do that up there. That's just me showing how to work with R. So sometimes I think people just look at what I'm typing and then just type it. But I'm like, no. You're meant to like follow along and like ask questions. And so great job. Yeah, good job. I've just had people turn in assignments. They're like, well, you wrote this. And I'm like, but don't. So I write that right there so people don't copy everything I copy. Okay. So let's find out. Let's do like a cost vector. And let's say my fake question. Make a cost vector per minute. Find out what % of R-rated movies cost too much. To be defined. Okay. So we're going to make a cost per minute. Does that make sense? So think about how we would make a cost per minute. Does that, Alexander, how would we make a cost per minute vector for a movie? Like how much each minute of that movie costs to make? Just think about like, we have how long the movie is. We have how much it cost. So then we can figure out how much that movie costs to make, like per minute. Like each minute of that movie costs us this amount of money. And then we could be like, oh, the movie's overpriced. Like if a movie's really long, like Gettysburg or something, it probably costs a lot to make. If a movie's super short, like a 5-minute art film, it shouldn't probably cost $20 million or $100 million. Like longer movies we'd expect to cost more. So we're going to like standardize this right here of sorts to say like the cost per minute of the movie. Budget by runtime, boom, right there, 100 points exactly. So we go to movie. There it is, movie. I like to autocomplete stuff. That way you know you typed it in correct. There you go. You see, look. Movie. Oh, it's capital. There we go. And then you set it correct. Budget divided by movie, autocomplete, and then runtime. So now that is the cost. And let's go right here to movie. And what we're going to do is we're going to store into this. Don't overwrite the data frame, but let's say cost per minute. So what I did was I created a new variable on the data frame right here. So by using two variables, I have now created a new variable here. So the new variable has been appended to the end of the data frame, and we could quickly look at it by clicking here and just scrolling to the end and sorting. It's going to sort for me. There it is. Ooh, look at that. The super expensive movie was Pirates of the Caribbean on Stranger Tides. Was one of the most. It is the most expensive movie per minute. That's crazy, but it did have a pretty good. Well, I mean, look at this one. This one right here. What was that? That is Star Wars: The Force Awakens was better. Cheapest movies cost per minute. That's a good one too. Exactly. Paranormal Activity. Oh my gosh, yeah, that movie made a ton. Paranormal Activity, super. That is, yeah, that made a lot. 2009. That movie cost so little. That's in millions of dollars, I think. So that cost $26,000. Like I could go pay for that movie right now. And then it made 221 million at the box office. So that's a good investment right there. So let's say a movie that costs more than 1 million per minute costs too much. Does that make sense, Alexander, right there? That's some high ROI. Now we have a movie that we can't get because it doesn't have a runtime. Beer for my horses. Okay, well, this is NA, means it's missing because it had no runtime. Maybe it doesn't exist. I don't know what's up with that, but we can't get it. It has no rating or 0 for the rating. But these are our movies that cost too much, we're saying. This is our fake example. So how do we see if a movie costs too much? We see if a movie costs too much by doing the following. Let's say more than 1 million per minute. Okay. So we go here and we go movie cost per minute, and we say is greater than or greater than 1. So those right there are the movies that cost too much. But here's the thing. I want only the R-rated movies that cost too much. So what should I do to my data right now to get only the R-rated movies, Alexander? So think about what I should do to my data, because this is the movies that cost too much, and I could find out how many of them, or the percent by doing mean. Mean will take the average of that vector. Oh, we have to do NA remove equals true. Or NA remove. NA dot remove equals true. There we go. 25% of all movies cost, quote unquote, too much to make. 25.7%. But how could I get just R-rated movies? You don't have to worry about the full code, but what is the theory behind it? Yeah, so that would do it right there. That's a good way, Alexander. Watch this. We're going to do it a few ways here. So let's do it like 3 ways. Alexander suggested a perfect way right here, which I do love. This right here will tell us. We just copy paste it. Movie. And so these are the movie rows. So let's say rows. And so now if you take a look at what Alexander gave us, if we put rows right here, these are the R-rated movies. And take a look. It's going to be really clear if we store this. Let's say R-rated. And take a look at the R-rated data set. Right there. We have confirmed that all these are R-rated. Does that make sense what I did right there, Alexander? I took and I made the rows you gave me because you said which movies are R-rated. So you found the positions of the R-rated movies. I stored it as rows right here. I could have technically done it just right here. But then I took the rows that you found, because this finds the rows. So that says, tell me if a movie is R-rated. Then return to me which rows they're in, like the positions of them. That's what a which does. It returns the positions of the true elements. We can see right here, here's the true elements. And then the which turns it, and then pull them out of movie exactly. So now we just have R-rated movies. There's many ways to do this. Another way to do this would be to go to subset, movie, and then go to rating equals R. And those are the R-rated movies. And we can confirm this by going to R-rated 2. And R-rated 2 has the same sample size. So that's another way right there. That's just same work being done for you right there just to get R-rated movies. If you want to sample also, another thing you have to do %in %. And this would say sample things that are contained within this vector here. So we could get R and G rated movies and R and G rated movies. And there's the R and G rated movies. I guess there's not that many G rated movies. Probably maybe not big money makers for studios. But you have to use the %IN percent to say contained in. One last way of doing this, which is probably one of my favorite ways of doing it, is to take movie, and this is a pretty interesting way, Alexander, right here, and then go to filter, and filter rating equals R. I think that should do it. Oh, I didn't load up dplyr. dplyr, and then there is the R-rated movies. And then we could also probably do summarize right here. But this is a way to do it. Also, dplyr, exactly. The %IN percent means contained in, and then the pipe right there. But you could do other things right here, like select. You could actually just select like rating right here, and that just gives you all the ratings. You could also select another column, but select just gives you certain columns like cost, and actually auto-completes, which is super nice. So you can actually select columns, do those different things right here. We could probably graph it right here and all this good stuff, but I absolutely love the methods of dplyr. I look at dplyr like SQL for R, exactly. It's pretty neat. It's data manipulation right there, but really powerful for working with data right there. So here was 3 methods to get the R-rated movies. Alexander, great way to start us out, giving us this method right here. Method 1, you only have to know one of these methods. Method 2, and method 3. So once we have the R-rated movies, once again, I would confirm we've created an R-rated movie subset right here by just looking at it, and you could try sorting it. And as long as it just stays R-rated, you're good to go. So now I want to look at the same code we did a moment ago, where I look at it, but change the data frame over to R-rated. And now we have the R-rated, and only 9.7%. So R-rated movies are not too much right there. But you want to see something really crazy? I wonder if we could do it. No, I might have to do a custom function. There's always Blake, great to see you here. But Alexander, how are you doing on this one? Because that pretty much covers everything right here. Like, you would need to create your success vector right there, having a performance greater than 1. So the performance vector you have to create on how it performed. Make a histogram of the values of performance. So you could do the same thing on cost per minutes right here. But I want to show you something. Watch this, Alexander. Here's the really cool thing. Let's put a new mark right in here. Okay, BS 474, assignment 1, making awesome graphics. You ready for this, Alexander? So for that question, we only want the proportion of only R-rated movies that are a success. The proportion of R-rated movies that are a success. So it'll be very similar to what I did right here, but you'll have a success vector. Does that make sense? You'll have a success vector. Exactly. So you just want the proportion of R-rated movies that are a success. And with this also, watch this. Now, if you don't have ggpubr, what would you have to do to get ggpubr? If you do not have ggpubr, because I'm going to talk about how to do some graphics here real quick. If you don't have it, successful R-rated movies. Oh, but you can just do the mean of it. So you can just do the mean right here to see if it is a success. And this will get you it right here. So you don't have to figure out, like this will tell you if something for me was over the metric. And so you could just do the mean of the vector. And the mean will tell you the % of things that are true. So you can just figure out if they were a success and then take the mean of that. Does that make sense, Alexander? Exactly. You're right on track right here. I might be on a delay. I will try and make sure everything's on ultra low latency for the next few streams. So I might have done some copying errors. But yeah, that's exactly what mean's doing. It's just dividing by the total length of the vector, finding out how many truths there are, and then dividing by. So it's doing all that work for you. But you could do it that way too. So awesome. So if you don't have library ggpubr, you'd want to go here to install packages and run this right here. And so this is installs the library. But here's the thing. ggpubr makes your life so easy. And I'm going to show you how little work we have to do to make some great graphics. GG histogram right here. Now notice, I want you to see, notice how when I type GG histogram, it says ggpubr right there. Might be off the side. It's right there. That tells you the package it's in. If GG histogram doesn't appear, it's because you haven't either installed ggpubr or you haven't loaded it via library. So make sure you have this. A regular old histogram doesn't look so cool. Like if we go to the R rated and we look at the histogram of this right here, we got to get the variable. It doesn't look amazing. I mean, not the end of the world, but that's fine. Cool. But watch this. GG histogram. And let me pull up an example of it because they got some really easy ones to use. If you do question mark, you can always get to the end right here. There's their data frame. There's the variable. And let's grab this right here. So we're just going to change the data frame to R rated. We'll change the variable. It has to be in quotes to this. We don't have a fill variable. So we're going to remove the fill. And the palette, FF8200. We only have one variable. And so we should be good on this. Don't fail me now. I don't know. Maybe it doesn't look better. Add density. False. There we go. There we go. And it's got the mean. We could add the median. There's the median of the data set right there. Palette. Oh, we need to go to color. Color equals FF8200. There we go. Oh, we'll go fill. There we go. Fill on that. Oh, look at us. We're getting better. Looking a lot better. Oh, gosh, right skew. Great job, Alexander. 100 points right there. Oh, my gosh, not class over. I forgot to show that in class. So there we go right there. And watch this. You ready? Here's what's really cool. If we go to plus labs, and then we say X equals cost per minute, and then we say in millions, guess what? It's literally just going to add that label right there. And then how do you think I'm going to add a Y label to say like frequency of movies or count of movies? How would I? Yeah, you just do labs for labels and you just add it onto it. You just say plus this. How do I add a Y label? Like, how do you think I'm going to, inside of labs, what do you think my next argument is for adding a Y label? And then we can make this graphically. Oh, yeah, that's just it. That's literally it. Just Y equals, then put it as a string and say count of movies. And then we recreate the graphic. Does it matter about something? Oh, I have being ignored. Oh, Y minus. Oh my gosh. There we go. Count of movies. How do you think I add a title? You could if there was a Z. You could if there was a. There's no Z on this one. I don't think it'll do it. It's not putting anything there. We want to add a title now. Should be lowercase title. And you just add a title up here to say, let's say, cost per minute of R-rated movies. And there you go right there. There's the title equal of it right there. And last but not least, I'm going to load one more package because I like this one. GG Easy. And you have to install that if you don't have it. And then you go right here and you go Easy Center Title. And you just run that. And there you go. There is our graphic. And if you look at how long that took us, it didn't take us too long to go from a kind of very simple graphic to one that shows the median, that has better access labels. We actually colored it in. But I would say you can make a much more complex, kind of cooler graphic. Exactly. And was it that hard to make? I mean, remember, I went over to help and I copy pasted this code. I just changed the name of the data frame. I changed the name of the variable. It had another variable right here, which might be confusing because they were doing like two variables. So we could actually go to the original data set. Now watch this. This is going to be crazy. If we go to the original data set, the movie data set, and let's go here to movie. So we're going to change this to movie now. And let's go here to fill. And let's go here to rating. Oh, it's mad. Oh, no. Maybe it's the palette. It doesn't like it. What about that? What does it say? Using bins. Oh, no, it did it. Oh, my gosh. It's too much, though. It does look kind of cool, though. It's too much. They're too overlaid. We'd have to, like, stack them. There might be, like, a stack. It's actually, like, it's a pretty complex graphic. It's, like, crashing it. It's got a lot of information. Oh, man. Is it not going to load in? But you can see it right here behind me. You can see the different medians. But yeah, pretty interesting. But that's you could save the graphic. Ooh, it's having a hard time with that graphic. A lot of stuff. TV Y7. Interesting how the differences. Do the G-rated movies cost the most or the unknown? You see the frequency of observations too. But you can make some pretty cool graphs pretty easily and pretty quickly. Here we'll delete this graphic. It's really having a hard time with that graphic. Oh man, we'll just make the graphic once, save it as a plot, and then you get it. But that's got a lot of information, got a lot of data points. You can make some pretty complex stuff pretty quickly with it. Yeah, as my R just crashes away as I try to make a simple graphic. Let's put it back to what it was. All right, there we go. Nice and easy there. Yeah, it's super cool. It's super powerful. And you look at how we went from, and I'll show you one last thing here, which is amazing. We went from a graphic that looked like this to like this, and it's in the plot, right? Oh, we got to go back. Just look at the difference, like the little effort from here to here. I mean, little, but I don't think it took too long. And last but not least is if you take and store this and go to Plotly and go to ggplotly, you can make your graphic interactive. So now we have an interactive graphic. Exactly. Just instantaneous, interactive to see how many observations are in each group. I think that's the frequency of each group right there. Or is that the frequency? No, it's the cost. There's the cost. Yeah. And it's how many individuals in a group and the cost per minute. I think it's probably doing the average of that group right there. And we can even hover over these points so we can see this last point right here, 3.43. We could even add things to the text if we wanted. Like we get super complex. You can make it so it tells you the movie. So that'd be pretty cool right there. Yeah, and you can even zoom in on it. So it's completely interactive, really neat. And all you have to do is take your object and put it into ggplotly, which turns it into a Plotly object. So there's so many options, and that's why I like showing these things right here. Just getting used to making ggplots. You can make some really cool graphics. Didn't know about the zoom in? Yeah, all you do is I think you can click. No, you have to double click to zoom out. You just double click to zoom out, but you just click to zoom in. And what other ones you working on, Alexander? Let's do another one. We'll hop back to the main screen, but let me know what you're working on. Okay, time for more questions. Whatever you're working on, let me know. Start of the semester, we'll throw 100 points, Alexander, for being here. What are you working on? Let us know. It is time for questions. Get some work done. Get some questions done. I'll be ruining a surprise, Alexander, but let's hear it here. We got 14 retweets and 14 likes. Here we go. Check out this tweet right here. We're trying to catch the attention of Rick and Morty and Adult Swim. 14 retweets, 14 likes. Said like 2 people clicked on the link, which I'll take. Oh, got a few more. Engagements, 80. Nice. It's got so many statistics now. I didn't know Twitter had all these stats. And then it's like, I can switch to professional, but I don't understand that. I don't understand Twitter. Drop those questions if you got them. Let's see, I haven't even viewed Nick Brown's profile. He's got about as many people on Twitter as I do. He and I use Twitter about the same. I love it. I love it. I am working on data analytics. Taking a random sample, and the instructions say screenshot all of the results. The example is only yes. Here, let me pull up Jump and let's talk about that. Just of the one. I can show you right here. I'll do it. Thank you, Blake. I'll show you. I already did my license. Is that because it wants to do Jump 15? I updated my license a few days ago. I'll get it pulled up right here and we'll do it, Blake. That way you can confirm. Where's that Jump 15 license? There we go, got it. License has been accepted. One more song right here. We'll get started. Okay, let's talk about Visualize Data Analytics number 1. Data Analytics number 1. Let's go do it. Here we go. Okay, so Data Analytics number 1. I'm actually going to pull up the assignment right here while we talk about it to make sure we get everything done. So using the diamonds file, let's go get that diamonds file. You will take a random sample of 200 plus the last 2 of your UTID. So we got to pull up the diamond file right here. Open up the diamond file. There we go. Diamond file. Diamond. There we go. So the diamond file right here has a bunch of different things about diamonds. An identifier, which is unique for every diamond, so that can't repeat. Carat is how many carats, so that's quantitative. The cut is a categorical, which is actually would be ordinal. We can actually switch it to ordinal because when you think about cut right here, and you don't have to do this extra stuff I'm doing, there is actually an order to it. So cut should go fair, good, ideal, premium, very good. Very good should probably go there. Ideal. Maybe ideal goes there. Premium sounds good. Okay, cool. And color. Color might also have a gradient too. Clarity might also be ordinal. Price is quantitative for certain. Color category. I don't know if that's ordinal or not. Clarity category. And grade category. Okay. So now we have all our data right here that we can look at. Categorical, quantitative, main things to know about. If we knew more about diamonds, we might be able to tell you if clarity is a ordinal or not ordinal categorical variable, if it goes in an order when we talk about it. Like order always means like from best to worst or like rare to well done. It has to be put in an order when we talk about it. So let's go here to tables. Let's go here to subset. Let's go to random sample 200 plus the last two of our UTID. Make sure it's yours. I'm going to type in 11 right here. That's going to be mine. I'm going to hit OK. And now we have our random subset. Now, here's what you want to do. You ready, Blake? When you take your screenshot, make sure my screenshot's up right here. When you take your screenshot, take it here like this. There we go. Now, what you're going to do is you're going to go to a Microsoft Word document, open a new one, file new, and drop that in there right there. There you go. You now have it in there, and this is all you need. So when the grader is grading this, well, put your name at the top. So put your name at the top right there. I've added my name, Brian Stevens. Put it in caps so you can see it right there. Put it in caps or not caps, doesn't matter.
It doesn't matter.
And the grader's going to look for this. They're going to make sure you have your name. And they're going to make sure you also... Really? They're going to make sure you also have... random sample of 200 plus your UTID. That's what the grader will be looking for. But then also, if you want that Discord bonus, head over to Discord and then go over to the Stat Nation Discord. And if you're posting in like the 201 channel or the 320 channel, you'd want to go over here and post, take a post from yourself. I'm going to go grab a post from me. Posted today. Probably this would be enough right here. You'd want to add this to the end. Does that make sense right there? I've actually been counting that as people's names too, because some people have been forgetting their names, but if you include the Discord channel, I'll include that as your name. Don't know if all graders will do that, but this person would get 101. So Blake, does that make sense right there? That's data analytics assignment 1. I hope you've been completing it as we've been doing this. That way you can get that grade, get that 101. How's that looking, Blake? Any questions? Great job. So this is what you'll turn in right here for the first assignment. Like, it's got your name, it's got the random sample right there, and then you put the Discord screenshot if you want to get that 101. Just message on Discord. I'll be replying more on Discord here in a moment or after office hours. But any other questions about the first quiz, about the first homework? We did all the quiz questions today, but we can always do more. Grab some lunch here in a moment. Always need that extra coffee. Well, let's head back to the main screen and chill out here. What questions are there? It is just relaxing office hours today. Let me see what Discord's saying. I think someone tagged me into a one chat. Is this correct? Okay, let's see right here. Great job, Rhea. Posting. Awesome. For the last question, is there any way to do filtering on the proportion in one line of code? Ooh, good question. So I've done the chapter 0 quiz and chapter 1. Am I missing anything for this week? The homework, I think you've done it all. And we'll look at Alexander's question next. Great. I think you've done it. Blake. 100 points, Blake, right there. Great job. Chapter 0 homework. Chapter 1 homework. Chapter 1 quiz. Data analytics. I think you're done till September 8th. Can you believe that, Blake? You're done till September 8th. How does that make you feel to be like, I'm done till September 8th. I got it all done. Got 101. I've got over 100 in the class right now. That's what we like to see, Blake. That's another 100 points. Keep it up. That's really awesome. I like hearing that. I think if you keep doing the work and make it manageable, it's like just start early, ask questions, and get it done. Time to work ahead. Exactly. Yeah. And do you want to hop on here anytime and ask about chapter 2 or anything? Just let me know and we can work on it. We'll make sure you get those good grades right there. When doing it in the mean and the middle. Yeah, let's do it. Alexander asked about last question. The last question. Okay, let's go to the very last question. Okay. Is the clustering standardized to have a mean of 0? Is it here, let's go check out Alexander. You ready? Which one is it, Alexander? It's for the last question. Oh, the last question we looked at. Okay, yeah, let's do it. 5A. Okay, like let's write that here. 5A. I was like, last question. Okay. Let me get this ready. We're gonna jump over there and do this. Okay. Let's say 43. Oh. Yes, let's say what? 1 question 5 in one line. Okay, let's go check it out here. Okay, so remember in this one, we're practicing. I'm doing a little bit different. Oh, no. Like, let's try to do it in one line. Let's try to make our code even better right here. So you can always make your code longer. Like, it just depends on how you want to code. So dplyr might be the best way to like pipe something through. So in my fake question, remember, let me just highlight this like 10 times. Brian does similar but different work. Like, I'm going to do similar but different work again. So if I wanted to go right here, if I wanted to create, watch this. I'm going to take movies, and I'm going to go here to mutate. And I'm going to take, inside of movies, I'm going to go here and say, let me reload everything. Like, I'm going to pretend we haven't done all this, okay? And I'll show you the power of dplyr, Alexander. Okay, so now we've got the original movies created, and we're just doing a different but similar thing right here. So mutate, and let's say cost per minute equals budget divided by, it's price, right? It should be price. Runtime. Movie's not found. Oh, movie. There we go. So mutate does it for you. Does that make sense? Mutate actually creates the new vector on the side of the data frame. It's not here because I didn't save it. But when you use mutate in dplyr, it's actually creating this. So I'm just going to call this M2 for the moment, just so you can see M2 actually has that vector at the end of it. But as I'm working with this right here, it is currently created on this object. So now I'm going to go here and I'm going to, what do you think I'm going to do next? I just want R-rated movies, Alexander. Now I just want R-rated movies. And this is the pro stuff, Alexander. This is why I'm doing this. You're asking a great question. Remember what I wrote last time using the dplyr methods of doing this? And you have to have library dplyr loaded up. So make sure you have it installed. So make sure you have that. But what do you think I'm going to do now, Alexander? What will I do now? What step will I do now? So now I only want R-rated movies. Filter. So now rating equals R. So now that's just the R-rated movies. And then we could take and we could go to select, which takes just columns, and we could select just this. So now that's just that vector. And now we might be able to tell if it's greater than 1. It's right there. So that took the whole thing. There it is right there. There's the one-line solution. So, and then, yeah, you see it right there. That's the one-line solution to it. That's, or one just continuous code of doing it. Yeah. No, really great question. So just think of it as a pathway. Like, the end of it, like, what you could possibly do is you could store this as like, or vector. You could store it as a vector if you wanted to do in multiple lines, and then go to vector greater than 1, and then take the mean of that vector right here, because that's what we're doing at the end. So that's the same answer right there. But you could do it as one line as we saw, rather than storing it right here. You could just say, you know, what percent of this? I would probably take and evaluate it, and then do greater than 1, and then take right here and take the mean of that. But then you have to throw one more around it. So we should be fine with this right here. There we go. Headed out. Awesome, Blake. You're welcome. Love the office hours. That's great to hear. That's great to hear. We might end a tiny bit early today, Alexander. So I think we're going to end a tiny bit early. I'm setting up. I got to get things arranged. But any other questions, Alexander? Keep those questions coming in. And great job working on this. It looks like you're really far into it. You're welcome. You're welcome. Let me know. I'm going to be replying to some emails, getting some stuff ready. But until then, we'll be back, everybody. I got to rearrange office hours a little bit because I got to change time. I went and did all of it. Oh, my gosh. Alexander, that is awesome. You thought it was due on Thursday? It was. It was. It's due next Thursday now. Until then, bye for now, everyone. Bye.